This will help you master activation functions. I drew many different types of data and many different activation functions, so you can understand which activation functions fit different type of data and which ones work best for which data. I drew many different types of data and many different activation functions, so you see which type of activation function fits which type of data. For example, you see this is struggling to fit this data, but this activation function ReLU is actually a bit better at fitting this weird data. This is tan-age activation function with quite a few weights and biases, so we have 3 weights, 3 biases, and it's converging quite well in this case. But we see a problem here, so maybe we need a bit more neurons, so another neuron would reverse this part, so it goes down like this, for example, because negative weight can reverse that part. Here you have formulas of the neural network, so you can understand better what's happening. And values, and you can see if you take this x and you pass this x through this entire function with these values, in the end you will get like good outputs that match this y, the function. Check out this repository activation functions. I'm gonna leave the URL below and you can go ahead and check all of them. So here we are fitting a linear function with tan-age, which is gonna fit but not so well. So this is a bit of a mismatch. And then we have a ReLU trying to fit a line, which is still a bit of a mismatch. But in this case, leaky ReLU will fit a bit better. So maybe this function is a bit better than just ReLU in this case. Look at the sine. Sine looks pretty funny. So sine actually fits this part well, but sine is periodical, so it cannot actually fit a linear function. But you know what can fit linear data? It's linear activation function. Although I've never heard of it, but I guess it works here. But the neural networks are very small for this kind of data. So you see here, it starts fitting it well, but it just has 2 neurons, so it's not enough. And it was still training, it was still trying to fit, but I gave it limited number of steps. So maybe if we increase learning rate, this would fit faster, the function. Here we have identity activation function, which is so funny. I've never heard of identity. And it's trying to fit this cubic, which actually looks quite close, but we don't know what this data looks down below. Maybe it goes down like crazy. And this is tan-age trying to fit cubic. So if it had maybe a few more weights, it will be able to reverse, because you see it's kind of reverse here. So some of the weights could have minus sign and it would flip entire function, and maybe it would fit them better. So all of these neural networks with just 2 neurons have definitely too few neurons, and that's why they're not able to fit these functions. ReLU here is quite interesting. You see some of the biases are moving it left and right, and the weights are determining the slope of this. Down at the bottom you have instructions on how to use this yourself. You can copy this into clone this into your cursor or whatever, maybe AI IDE, so you can chat with AI how to use this. Check out other videos on my channel, especially this coding Qwen 3 from scratch and coding GPT-5 from scratch, and see you next time.